Hello, and I want to welcome you to a video discussing quadratic functions in the form f of x equals ax squared plus bx plus c. From going from standard form to this form, just distribute out the x between distribute the k among the x and the negative h in the parentheses. Use the square term and just solve, and you will have the form that we're going to be discussing now. Now, this is pretty straightforward. For these examples, determine the coordinates of the vertex for the parabola defined by the given quadratic function. If you remember, there are two ways a parabola can look, or the graph of a quadratic function. It can either look like a U or an N. And the vertex is the very tallest or least point on that parabola. For example, right here would be the vertex, and right here would be a vertex. So determine the coordinates. First, what I'd like to do is go through and identify what A, B, and C are. Whatever has the x squared term with it is going to be A, so 2. Whatever just has a plain x is going to be B, so in this case 4. And C will just have the regular number, so negative 1. Okay, so does this parabola open upward or downward? And what we have to see is if A is negative. If A is negative, it will open downward. If A is positive, it will open upward. In this case, 2 is positive, so it's going to open upward. Now what we have to do is follow this x equals negative b over 2a. This is going to give us the line of symmetry. So when we do that, we're going to have negative b, which in this case is 4, over 2 times a, which in this case is 2. We're going to simplify negative 4 on top over 2 times 2 is 4. So we're left with negative 4 over 4, or just negative 1. Okay, now what we want to do is take what we just got in for x. Let's go ahead and box it in. And let's plug it in for the function. So f at negative 1. So go back up here, and our function is 2x squared plus 4x minus 1. So for every x that appears, we're going to put a negative 1 in its place. So 2 times negative 1 squared plus 4 times negative 1 minus 1. Let's go through and simplify. F of negative 1 equals negative 1 squared is just 1 times 2. Then 4 times negative 1 is minus 4. And then we have minus 1. Hang on. Continue to simplify. We have 2 times 1 is 2 minus, and then negative 4 minus 1 is going to be a negative 5. So f of negative 1 is going to yield negative 3. So we'll combine our x value of negative 1 and plug in what we got in for the function. Once plugging negative 1, so it's going to be negative 1 comma negative 3 as our vertex coordinate. Okay. Now let's look at number 2. Number 2, we have f of x equals negative 3x squared plus 12x minus 2. A has the x squared attached to it, so it's going to be negative 3. B has just a regular x, so it is 12. And C has a negative 2, because it's just a regular number. Now plugging into our x equals negative b over 2a, C, in this case negative, let's plug 12 in for b, over 2 times negative 3, which is a. So we have negative 12 over 2 times negative 3 is negative 6. So negative 12 over negative 6 is just going to yield a positive 2. So now let's take our function and plug in what we got for x, which was 2. So every x that appears in the original function we'll replace with a 2. So we have negative 3, replace x with a 2, squared, plus 12, replace that x with a 2, minus 2. Let's go through and simplify. We have f of 2 equals negative 3 times 2 squared is 4, plus 2 times 12 is 24, minus 2. So let's continue to simplify. f of 2 equals negative 3 times 4 is negative 12. Okay, and then over here, 24 minus 2 is going to be 22. So f of 2 equals 10. Now let's take our x, which was 2, comma, and then we got in for the f of 2, which is 10. So that makes the coordinate pair 2, comma, 10, telling us that's where the vertex is located. With our next example, for this function is in this example, we need to graph it. So let's first identify what a, b, and c are. There's the coefficient of 1 in for that x squared, so 1 in for x, negative 2 in for b, and negative 8 in for c. Now we have to determine if it opens upward or downward. It's going to open upwards because a is positive. And let's see, it opens downward for this last example. Forgot to document that. So let's do just what we were doing before. Let's take negative times b, which is going to be a negative 2, over 2 times a, which in this case is 1. So we're going to have negative times negative is a positive 2 on top, and then 2 times 1 is 2, so 2 over 2 is just 1, and for the axis of symmetry. Okay, now let's take what we have in for the function at 1, which was our x value. So every x that appears in the original function, let's replace with a 1. So we're going to have 1 squared minus 2 times 1 minus 8. Let's go through and simplify. F of negative 1 is just going to be 1 squared is 1, minus 2 from negative 2 times 1, minus 8. So if we go through and simplify all of that, you're going to have just a negative 9. So that makes the coordinate pair 1, comma, negative 9. So 1, comma, negative 9. There's that point right there. So now what we need to do is say when y is 0, we have to factor. So we're going to have our function of x squared minus 2x minus 8, which is our function. We're going to set it equal to 0. Now we need to factor, and the terms of 8 that when we add or subtract them together, that give us 2, knowing that 1 will be a plus and 1 will be a minus, with our x giving us x squared, would be 4 and 2. And 4 has to be the bigger. We go with the negative because we want a negative in the end. Now if we break these apart, we have x plus 2 equals 0, and x minus 4 equals 0. Let's solve for the variables by this first subtracting 2 on both sides. So we have x equals negative 2 as an x-intercept, and we're going to add 4 on both sides here to have x equals positive 4 as another x-intercept. So let's document that. X at 4 would be this intercept, and negative 2 would be this intercept. Note that the axis of symmetry will be the vertex's x-axis, meaning what happens on one side of the line will happen on the other, like a mirror. Now we need to document where the y-intercept will be. To do that, all you have to do is plug 0 into every x that occurs. So we're going to have f of 0 equals 0 squared minus 2 times 0 minus 8. If you simplify all of that, you're going to see that f of 0 will strike at negative 8. So that makes really the point 0, comma, negative 8. Just go ahead and document that, which is right here. And of course what happens on one side happens on the other, so there's another point. So now let's connect our dots best that we can, making it look as neat as possible. Okay, now we have our graph. Let's look at the domain and range. Of Of course, it's going to go forever in the negative direction for domain, the positive direction for the domain. Now, for the range, it will be, in a bracket, the x, which is going to be 1, comma, positive infinity. And then we're going to put the ending parentheses showing that infinity is not included.